So I want to take a little closer look at the parts and the tools we're going to use to assemble this OSI 400 CPU card. Reminder of why we're doing this in the first place is I have a MOS 6501 here. Actually, this chip here is a MOS 6501, and then I have a 6530-004. So this is a pretty rare processor. This is 24th week of 75, and this is a 6530 implementing TIM, the terminal input monitor, terminal something like that anyhow, a simple monitor system where you put values into memory, run programs, that kind of stuff over a serial link. So that's what inspired this, was seeing these MOS 6501s. There's been 2 sell on eBay in the last couple of months here for astonishingly large amounts of money. And I just happen to have one. So I want to test it, see if it works. And so that's ultimately the goal of what we're going to build here. The OSI 400 main board, this is a reproduction, can take a 6502, a 6800, or a 6501. The 6501 and 6800 are the same pinout. Electrically, they appear the same, even though internally they implement a completely different set of opcodes. So I picked this up from the Glitchworks. It's a reproduction of the OSI 400 CPU card. It actually is silkscreened on the back, which the original card wasn't, which makes soldering a little bit nicer, and it has plated through holes. The early boards didn't, the later ones did. I picked up the full kit. So the kit includes all the logic here and RAM. We've kind of looked at this, I think, in the previous video. But RAM, logic, the 65A monitor ROM, and this is the 65A is for the 68,000 or the 6501. Or, let me step back. The 05165A monitor is for the 6502 or 6501 processors. There's a 6512. It's processor. The display of the 6512 is basically pin compatible with the 6501 with one minor difference. There's a couple of transistors here if I want to implement RS-232 level shifting, which I probably won't do. I'm not completely decided yet on how we're going to do this. Get these back into some kind of protection. And of course the MOS chips are the high value parts here, and I just kind of want them out of the way and protected. I have sorted the parts, as I often do before the kit build. Of course, this assumes I can get it open and not shoot parts everywhere. Machine pin sockets were supplied with the kit. I've kind of sorted them here into 40, 24, 16, 14, and 8. These are the edge connectors for the various spots you see here on the edges. There's a set of components specific to a 555 timer here. This is for producing the core frequency for the baud rate generator for the I want to say ASIC, and that's the wrong term. There's a serial adapter, an RS-232 adapter. Really just a serial adapter here that sits in this spot. That produces the clock for it. There's a couple of capacitors up here that go with the 74-123 dual one-shot that have to do with producing the two-phase clock for the 6501, and again a stable clock. These are NPO capacitors, the same down here, so they're very low drift over temperature, decoupling, and there's a mass decoupling electrolytic here, or that might be a tantalum looking at it, and some disc caps. There's resistors. So all the parts basically to get the core board stuffed here. I'm going to do my best to use the various pin bending tools I have here. There's some places where resistor widths vary. I've actually produced what I often end up doing is a component location diagram drawn big enough that I can see it easily. So there's a bunch of 4.7K ohm resistors here, which happens to be there in the box. There's that large bulk capacitor here, the 555 down here, the dual clock generator here with the NPO capacitors there, etc. This will be my guide to assembly, really, to get the resistors in the right places, the components in the right places, As you can see, it's not going to be too long a build. The green lines, if you can see them, are meant to show how to configure the board for the 6501/68000. I'm not convinced I have this totally correct. We'll find out. And then this green brings serial out through an inverter. And I've got serial out, serial transmit connected up here, and serial receive connected here, with VSS on either side is the way I've configured this. I could also bring the serial out over here on user signals. With the TIM connected, there's a port that'll sit here, an output port, that can be talked to, that I may wire up to this just to generate, an output port that we can talk to light LEDs or something to show the monitor's actually working. We'll see as we get there. The board requires -9 volts DC for the 1702 EEPROM that goes here. With the OSI 65A monitor. I know there's a lot of blue on here that doesn't show up well against the blue background. This didn't print nearly as well as it looked. But that's basically my guide to building this. And again, it's a document I produced. The cool thing here, and I've never used this guy before, is this was picked up new old stock for $1, and it is a lead bending tool, and it's a very nice, thick, heavy lead building or bending tool. And of course it's SAE, quarter, 9/16, 6/8, 11/18. I mean, it's got all of these unusual widths on it, and some of that will be replicated on these. 0.5 to 1.5 inch, 0.4, with various body widths. I just thought this was a cool addition to the little collection here. If we grab one of these resistors, we're going to have a bunch of 4.7Ks here. And I don't know what that spacing there is. That's pretty narrow. Well, it's 300 mil. It's 300 mil apart. So it's going to be 3/8 might fit, and it might not, and it won't. So I will try to use this wherever I can. There's a couple of resistors up here that are on about 7/16 centers, maybe. We'll see if I can, actually use the lead bending rigs or not. It's always hard to say, but I just thought this was a cool find, a cool addition here to the collection. So anyhow, let's jump in and solder. So I'm going to start with the 4.7K resistors here. There's 8 of them that go into a 300 mil, 0.3 socket there. I happen to have a bunch of carbon film resistors in my stock, and I've done a bit of experimenting with these to figure out if any of the bending tools would work, and really none of them will work. Even this guy down on the 0.3 just doesn't get it close enough, and what it appears I'm going to have to do is manually bend these. So I need to pull out 4.7s. Yep, there's 4, 5, 6, 7, 8. These are period correct resistors. They are carbon film. They have the square ends, so they are more stable. I think Burr Brown probably manufactured these. You see larger ones of this style in a lot of old tube electronics. They're typically larger. They're bigger than the 1/4 watt. These are, but the bigger brothers of these, the higher wattage, tend to be, like I say, very stable. It looks like to me I'm going to have to manually bend these as tight up against the package body as I can, and try to bend them so the part is somewhat straight. So, that is what it is. That's not uncommon, but that does drop in well like that. I need something to kind of hold this up. We're going to go ahead and pre-bend all of these. Get the soldering pencil heated up. I've always wanted to build an OSI system. It's something I really have no time with. I remember seeing them back in the day in various magazines and wanting one sometime in the last 2 years on eBay. There was an OSI, I want to say 800, but I know that's wrong. There was a system with the blue boxes, or brown, maybe they were brown boxes, backplane, CPU card, memory, and external 8-inch floppy drives. And it sold, that's where the 800 number come from. It sold for about $800, and I was really tempted to bid on it, and in the end didn't. At the time, just couldn't justify the spend. But you know, Glitchworks has reproduction boards. You can still find, you know, vintage components. The OSI 400 PCB you see here, he actually has stores on Tindie. You can actually order the vintage look parts kit. I think a non-vintage look parts kit as well, and various CPU options. And so you know, you can build, this board can be built up as a single board computer, which is what I think I'm going to do here. I don't have all of the required components to make it single board, in that I need to provide pull-ups on the external buses here to get the thing to run single board. Typically the board expects to be in a machine with a bus, and the pull-ups are provided on that bus. So those aren't as cleanly in as I would have liked. There's not much I can honestly do about it at this point. It just kind of is what it is. I'm going to use a little bit of, I think I'm going to use some flux here as well. Let me get the soldering glasses over here. Just because these leads are pretty nasty. So I am going to use flux. Hopefully not gallons of it here. Well, that's gallons of it. It is what it is. This is Kester, a 951. I quote, no clean flux. We all know better than that. Wait for the tip to come up to temperature. Try to keep my head out of the way. Let's see if I can get one of these to take solder. I'm going to shift the board so that leads down here on this end are straight. I don't normally solder ends like that. I normally kind of work my way across the board. Hopefully my head isn't too much in the way here. You can certainly hear the solder. I'm trying to roll the resistor around a little bit so the legs are coming through the PCB square. That's why you kind of see my hands shuffling a little bit right and left here. These are pretty much locked in place by the ones next to them now. If I can get in there. Let's take a look at those solder joints for quality. Well, the two end ones, the first two I did, are the best looking of the set. They all look okay. They seem to be well onto the leads. Those are crap. Excuse my French. I really need a new lead trimmers. Those are crap. I need to get rid of the bad ones. I really do. Those don't look too bad. I'm sliding down the lead with the cutters until I feel the top of the solder, and then I'm cutting there. Those aren't horrible looking solder joints. I'm happy with that. So we've now, by clearing those leads out, cleared out enough room to get in there and solder across the top. Get in here with flux. I think the flux is going to be critical on these old resistors, just because there's oxidization on the leads. Kind of get them bent where they're attempting to face pretty much up. This is truly a case where right temperature and flux and everything matters, just because they're so old. There's so much. Wow, that one is really not being friendly. Why am I having so much more trouble with these on this side? It's not like there's a lot more copper here. How well you can see, those look acceptable to me. Let me trim them. Excuse me, the solder joints are fairly consistent. My soldering isn't as consistent as it used to be, and I think that's just because I'm hampered a little bit by my vision as I get older. But that's 8 4.7K yellow, purple, red, 4.7 followed by 2 0K resistors in those first 8 slots. I am happy with that. That has worked out okay. There's now a smattering of other resistors. There's 2 more 4.7s over here, some 1Ks, 33Ks, some 22Ks. Actually, that's an 11K. I don't know what I said a second ago. I'll just mention it here. This is incorporating the clock stretching. So the 123 here is producing the 2-phase clock, non-overlapping 2-phase, driving through a 7417 to get it as close to 5 volts as possible. And what can happen here is when the 1702 chip select, when the EEPROM is enabled, this pin gets pulled low, and that basically brings this second 22K ohm resistor into circuit, or out of circuit. I believe it ends up out of circuit, but anyhow, it stretches one of those pulses to twice as long. It's essentially injecting a wait state because the 1702s can get rather slow. So it's covered in one of the app notes for the 6502, I think. Anyhow, it's covered in an OSI app note, and so we're just going to implement that directly. It's just a recommended implementation. So it adds, rather than an 11K ohm resistor here, it adds a couple of 220K and a couple of diodes. A few resistors down here. There's a 1K hanging out down there. There's 2 precision resistors up here. A 10K trim pot and a 1K down here, and that low drift NPO capacitor here. There's a 0.01 disc that goes on the back of the board because there's not a footprint for it. Anyhow, I am going to do these other components, at least the resistors. I'll do the resistors off video, and I'll see you when we get those all done. So I believe this finishes up all the resistors. We have a couple 4.7K over here, and yes, they are kind of a weird angle. A 1K, a 1K, and 11K. A 22K and a 22K. The 4.7Ks we put in earlier in the video. There's a 1K here, a 1K here, and there's 2 precision resistors down here. I don't remember the exact values offhand. They're all in, and you may be able to see that I've added the diode here that becomes part of the wait state generator. So that diode needed to be there, and then there'll be a jumper link from the pad here down to the enable pin through a diode as well. But we'll worry about that later. I think next, or in the next video, we'll jump in and deal with the sockets. So I hope to see you then.